All right, this video is going to go over the multiple choice questions from the Unit 7 review packet. Question number 1, 2, and 3 all revolve around this scenario here, so let's read it carefully. A researcher wished to test the effect of the addition of extra calcium to yogurt on the tastiness of yogurt. A collection of 200 adult volunteers was randomly divided into 2 groups of 100 subjects each. We got 2 groups of 100 subjects each. Group 1 tasted yogurt containing the extra calcium. Group 2 tasted yogurt from the same batch as Group 1 without the added calcium. Both groups rated the flavor on a scale from 1 to 10, being very unpleasant and 10 being very pleasant. The mean rating for Group 1 was 6.5 and standard deviation of 1.5. And the mean rating for Group 2 was 7.0 with standard deviation of 2.0. Assume the 2 groups are independent. Let mu1 and mu2 represent the mean ratings we would observe for the entire population, represented by the volunteers if all members of the population tasted, respectively, the yogurt with and without the added calcium. Referring to the information above, assuming the 2 sample T procedures are safe to use, a 90% confidence interval for these. It says use the conservative degree of freedom, but you can do this in your calculator. So here's what you're gonna do. You're gonna go into it, and this is gonna be a 2 sample T interval. So let's go ahead and write that down first. We know it's 2 samples because we literally have 2 independent samples here. So we're gonna go ahead and use a 2 sample T interval. And we're gonna go to stat, test. And I think that's option 0, if I'm not mistaken. 2 sample T interval. Go into stats. And let's put our data in. So mu1 is 6.5. S of x1 is 1.5. Our samples are both 100. x2, 7.0. And S2 is 2.0. Again, 100. And we want to do a 90% confidence interval. 90%. So 0.9. Don't use pooled. And go down to calculate, and you get an interval from negative 0.9133 to negative 0.0867. So I'm going to write that down. Negative 0.9133 to negative 0.0867. All right, that's our interval. Now let's talk about how to get all this other information from it. So notice it does not give you the difference. Now you know that middle number is going to be negative 0.5 because they're all starting with that. But if you have your 2 ends of the interval, you can get your point estimate and your margin of error by just taking the lower and the higher number and doing adding and subtracting and dividing by 2. So if I want to get that middle interval, that middle number, I'm just going to do negative 0.08 plus 67 plus negative 0.9133. I'm going to take that number, oh, it's 1. I'm going to divide it by 2. And of course, there's your middle number, your point estimate. As far as your margin of error goes, you're going to take those same 2 numbers, negative 0.0833 or 67 minus negative 0.9133. You're going to get that difference. And then you're going to divide that by 2. And you get a value of approximately 0.4133. That's your margin of error. You can also get that value by taking the higher number here, negative 0.0867, and simply subtracting that negative 0.5. And you'll get that same value that way too. So anyway, it's not exactly 0.42, but you can see here that's really awfully close to it. So we're going to, of course, use that one here. That's close enough. Remember, your calculator does not use a conservative estimate, so it's going to be a little more precise. That's going to be your margin of error, and that's going to be your sample mean difference there between x1 and x2. All right, number 2. Referring to the information above, suppose the researcher has wished to test the hypothesis that the null is that they're equal. The alternative is that mu1 is less than mu2. And let's talk about the p-value of the tests. Since we have the data in here, we're just kind of translating between an interval and a test. This is going to be a 2-sample t test versus an interval. And we have all that information in there. So we just want to look at our alternative, and you can see, well, it's less than. So we got to change that to less than. And everything else being the same, we'll go to calculate, and we'll look at our p-value. And our p-value is 0.023. So it's going to be a 2-sample t interval, or t-test. And your p-value is 0.023. So now we just look at where that falls, and well, 0.023 happens to be between these two numbers. So that's going to be your answer. All right, number 3, from the information above, which the following will lead us to believe that the T procedures were not safe to use. So just this would be like, what would be your red flag as to maybe not be able to do these calculations? So talking about going through these choices, the sample medians and means for the two groups are slightly different. They can be different, okay? That's okay to have. The distributions of the data were moderately skewed. Moderately is fine. You just don't want any strong skew or outliers. But moderate's okay. The data are integers between 1 and 10, and so cannot be normal. That's not true. The numbers have nothing to do with the data being normal, so go ahead and cancel that out. Only the most severe departures from normality would lead us to believe the T procedures were not safe to use. So that's talking about like the strong skew or outliers. And of course, that's the one that is going to be your answer, because anytime you have strong skewness or outliers, that's going to depart from that normal condition being met. The standard deviations can be different from each other, so don't worry about that. It really has to do with that normal graph in this situation. All right, next video, we'll go over the next set of questions.